class 130.
Yes, sir.
Okay. So my dear student, in the last class we have studied stream properties and we have seen some of the mathematics. So I think that you practice well in your home because that is very important for the exam. So today is our basic topic is entropy and Molier chart, and Molier chart is a very important parameter for the mechanical engineering. They use this chart for various reasons. Okay, but we will just know that how to operate this chart and what are the components of this chart and what are the functions of this chart and how can we get the different values from this chart. And before that, we all know that entropy, enthalpy, this topic we already know, but entropy is a very uh, difficult word to explain, but still we can consider this as a heat, uh, entropy as a heat, but there is a difference, basic difference between entropy and enthalpy. Enthalpy is a total heat of the system and entropy is heat per Kelvin. That means per degree Kelvin temperature difference, the amount of heat, that is called entropy, and it is also known as the disorder of the universe. Entropy, you can see that there are some basic lines that I have taken from the internet, that it is a thermodynamic quantity representing the amount of energy in a system that is no longer available for doing mechanical work. Okay, so doing mechanical work, that means it is not basically not used for doing any kind of mechanical work. It just increases the temperature, that's it. And another line, you can see the very interesting line. These are very confusing line for the students. The entropy, the measure of the system's thermal energy per unit temperature that is unavailable for doing useful work. That means basically it is per unit temperature increase, you have to give that amount of heat, but that is not available for doing useful work or mechanical work. So finally you can see that the entropy is basically unit joule per Kelvin. That means joule per Kelvin, that is the unit in the international unit system, the SI system. So finally, what I will recommend to all of you, that you can remember this entropy as a heat parameter, a heat energy parameter, but definitely that is joule per Kelvin. That means per Kelvin temperature increase, the amount of heat we basically require, that is known as entropy. Okay, so because why we discuss entropy a little bit much more, because of this chart. This chart is basically based on the two parameter. One is entropy, another one is enthalpy. So basically the Molier chart or the Molier diagram is also known as enthalpy entropy chart. Enthalpy entropy chart. Why? Because in x-axis it is entropy and in y-axis it is enthalpy. So that's why it is also known as enthalpy entropy chart, or it is also named after the scientist Molier. According to his name, this diagram is known as Molier diagram or Molier chart. Okay, okay. Let's see the chart. What is the chart all about and what are the parameters in those chart? And this is a generalized diagram of the Molier chart. This is not the actual diagram, but this will give you a overall idea that what are the parameters that is available in that chart. Overall idea. As I already said, this is enthalpy entropy chart, because in the y-axis it is enthalpy. We represent enthalpy as H. We already know that we represent enthalpy and H, and in the x-axis it is entropy, and we represent entropy as S, capital S. So we can call this enthalpy entropy chart or HS chart. according to their unit HS chart. Okay, so that's why it is known as the Molier chart, the Molier diagram, enthalpy entropy chart, or HS chart. All are same, just that there are different names are available. All are basically same. Okay, so you can see that the x-axis we have entropy, in the y-axis we have enthalpy. Okay, so these are the first two things that we have the enthalpy. There is a bold line. There is a bold line at the lower bottom in the Molier chart, that is known as saturation line or dry steam line. We all know that there are three types of steam. One is dry steam, one is wet steam, another one is superheated steam. And among these three steam, where dry steam is in between, dry steam is in between. So the bold line basically represent the saturation line or the dry steam line. Remember, the bold line, only one line in the throughout the whole graph or whole chart, only one line, that is the that is the dry steam line or the saturation line, only one line. And above this dry steam line, the whole region are superheated steam region. The whole region above this, the whole region are superheated steam region. And we all know that the main parameter of the superheated steam is the temperature. The main parameter of the superheated steam is temperature. And below this, under the area, under this line of the saturation, the whole region are known as wet steam region. That means it is the border. The dry steam line is basically as the border. Okay, the dry steam line is basically as the border. So below it is a wet steam region, and the dry steam line, above the dry steam line, that is the superheated steam region. So there are basically two regions. One is superheated steam region above the dry steam line, and below the dry steam line, that is the wet steam region there. So we already identify the three steam. One is wet steam, then the dry steam line, then the superheated steam region. Okay, last but not the least, the most important thing, we all know that it is basically built on the pressure. So the vertical, almost semi-vertical line, these lines are basically pressure line. In the graph you will see this type of line, those line will be the pressure line. Okay, so the vertical line will be the pressure line, and in the superheated steam region, the horizontally line will be the temperature line in the superheated steam region, because we all know the most important parameter of a superheated steam is temperature. Clear? And for wet steam, the most important parameter are dryness fraction. So all this line of this wet steam are dryness fraction line, because we all know that dryness fraction value is basically from 0 to x is less than 1. Okay, so this is the dryness fraction value for the wet steam. But when the x equals to 1, that means 100% steam generation, that means x equals to 1 is equals to dry steam. This is for dry steam, x equals to 1. But when the value of x, that means the dryness fraction value, is less than 1, then it is wet steam. So the lower equation is for the wet steam and the upper one is for the dry steam. Okay, so these are the basic parameters, I think that you already understood. Let's go to the main diagram. So this is the basically the overall and the main Molier chart or the diagram. Let's match our description with this. First of all, we will see that you can see in the x-axis it is the entropy S, and you can check the value 5, 5.5, 6. These are the entropy value. Okay, entropy value. And in the y-axis, you can see this is totally the y-axis. This is the enthalpy value. You can see that the enthalpy H per kg, kilojoule per kg. Okay, so you can see that the value of enthalpy, that is 2000, starts from 2000 and 22,500, 3000, and up to 4000, 4500, something like that. And you can also see, my student, here, if this is the 2000 and this is the 2500, in between there are 5 box, 1, 2, 3, 4, 5. So there are 5 box, and every box is 100. You see that? Because this is 2000, then 2100, 2200, 2300, 2400, then 2500. So every box is 100. Okay, so similarly, this is 2600, 2700, 2800, and up to 3000. So the main thing that I am trying to say, that every box is 100. Okay, in the enthalpy scale. Okay, so we already see the x-axis and y-axis. Let's look at the main bold line. You can see the red line. I take one more, another color, so you can distinguish. I'm taking the blue color. You can see that this blue line, that means the bold line, are basically which line? Can anyone tell?
Dry steam, sir.
Yes, this bold line are basically dry steam line or saturation line. Okay, you can see, if you zoom, you can see x equals to 1 here. Can you see?
Yes, sir.
Can you see, my student, that x equals to 1 is written on the line?
Yes, sir. 1.00.
Yes, x equals to 1. It means that 100% water has converted to 100% dry steam. Okay, so that's why it is written that x equals to 1. That means it is a dry steam line. It is a dry steam line. Okay, so my student, x equals to 1 equals to dry steam line. So this bold line is dry steam line. Let me check how many Bengali students are here. Sariar Shakline and Maruf Ahmed. Only 2. Okay, so I'm telling one more time, in the chart there is a bold line. The bold line is basically, I'm drawing with another color. The bold line is basically known as the dry steam line, because here it is x equals to 1. So below this line, the region is wet steam region. This is wet steam region, my student. Below this line, the whole region are wet steam region. In Bengali, যে এই মেইন যে বোল্ট লাইনটা, এই বোল্ট লাইনটা হলো ড্রাই স্টিম রিজিয়ন। এই ড্রাই স্টিম রিজিয়নের নিচের যে পুরা রিজিয়নটা, ড্রাই স্টিম যে লাইনটা, এটা নিচে ফুল
Yes, sir.
রিজিয়নটা হলো ওয়েট স্টিম রিজিয়ন, এবং এর উপরে পুরা রিজিয়নটা হলো সুপার হিটেড স্টিম রিজিয়ন। So my student, this whole steam region is wet steam region, and the main parameter of the wet steam region, you all know, that is dryness fraction. You can see here that 0.95, 0.9, 0.85, 0.8, 0.75, 0.7, all are these dryness fraction value. Okay, dryness fraction value, we can know. And if it is a 0.9 and if it is a 0.85, so what will be the middle one? Can anyone tell what will be the middle one value? It will be the middle of 0.85 and 0.9, probably 0.87. Okay, so we cannot go, my student, and I'm trying to say that we cannot go to straight because our scale is not straight. We have to go like this. Okay, we have to go like this because our diagram is not straight, our scaling is not straight, so we have to also follow the same way that has been showed. So my student, this is weight stream region, and in the weight stream region we have the dryness fraction value. Okay, these are the dryness fraction value: 0.95, 0.9, 0.85, 0.8. And what is the upper region? This upper region in the, from the bold line, you can see the bold line. If this is the bold line, okay, the upper region is basically superheated steam region. The upper region is basically superheated steam region, and we all know that at the superheated steam region the value is temperature, the superheated temperature. And you can also see here, if I remove this line, you can see this line. This is 300 degrees Celsius line. If I draw this line more, the green one, 350, then 400, 450, 500, 550, 600, 650. So these are all the temperature line, you know, 100 degrees Celsius, even 50 degrees Celsius. So these are all temperature line. Okay, my student, these are all
Yes, sir.
temperature line. So this region, the upper region, is superheated region, and the main parameters of this region are temperature, the superheated temperature. Okay, so we have already seen all the parameters except one is left, that is pressure line. You can see the blue line here, you can see this blue line here, the vertical blue lines. These are the pressure line. You can see here, this is 2, 4, 10, written 20, and up to 500 bar, or even 1, 0 0.5, 0 0.2, 0 0.1. So all the values are, all this vertical line are pressure line. So an interesting thing is, if you have to understand that the pressure line or the pressure scale are non-linear. That means in every box the difference is not the same. You see that in the enthalpy scale it is 2500, it is 2600, 2700. So every box is 100. That is linear, the change is linear. But in the pressure line you can see that this is 0.5, the next box is 1, so the difference is 0.5. Even this is 1 and this is 2, so the difference is 1. Even you can see from 2 to 4 the difference is 2. So this is non-linear, the every box is not the same. So we have to find out the value of every box. While using this chart, we have to be careful, because this is non-linear relationship between this pressure line. So we have to find out. Suppose you can see here, for example, let me suppose, where is 8? What is the 8 bar line? You can see this is the 4 bar line, and here this is 10 bar line. Okay, so where is the 8 bar, sir? You can see from 4 to 10 there are 3 boxes, isn't it, my student?
Yes,
Yes,
sir.
sir.
There are 3 boxes, and what is the difference between 4 to 10?
6.
6. So if we divide 6 by 3 boxes, so every box is
2.
2.
2 point something.
So no, not this 2 point something, every box is 2.
Yes.
So the next
Yes, sir,
line is
2.
6 and the next line is 8. Clear? So in this way, similarly let's check one more thing, that I want to know where is 35. I want to know where is 35. So how can I see, how can I check this, where is 35? You see that here this is 20 and 1 2 3, the third, this is 50. So from 20 to 50, how many boxes are here? Can anyone tell me that how many lines?
There's 2 lines,
4,
sir.
2,
No,
3, sir.
from 20 to 50 there are 3 boxes. Okay, and what is the difference? 30.
35. 30,
No,
yes, sir. 30.
30. 50 to
30 by 3.
30 divided by 3.
3.
So every
10.
box is 10.
10.
So this is 20. So the next line will be 30. And the next line will be 40.
40.
So the 30 and 40, the middle will be 35. Am I clear? That how
Yes,
to
sir.
find out the pressure line? That because we have to calculate individually, because these pressure line are non-linear. So that's why we cannot say easily. We cannot say easily. Okay. So we
Sir.
have to calculate like this. Okay, let's see that some of the examples that how to use this Molier chart. So let's see the first one. The first one, you see that using Molier chart, find the enthalpy drop. Enthalpy drop means the the total heat drop. That how much heat we need to, drop means less. How much heat we need to give up, and what is the final condition of the steam? Final condition of the steam, then is it wet steam or dry steam or superheated steam? And the process is when it is expanded isentropically. Can any student tell me what is isentropic? In the last probably before 2 class I told
Yes, sir.
isentropic.
Yes,
Can
sir.
anyone tell me what is isentropic?
Yes, sir. No change of entropy, sir.
No change of entropy. Yes, excellent. You said that no change of entropy. So that means that if there are two processes from one A to B, A to B, and if you change the steam from A condition to B condition, but it is told that the process will be isentropic. That means the steam, the entropy value at A point and the entropy value of B point will be same, because it is the process is isentropic and there is no change of entropy. No change of entropy. So on that case, it will be SA, the entropy SA equals to SB. Clear? This is basically isentropic process. Okay, let's check the example one more time. Find the enthalpy drop and the final condition of the steam when it is expanded isentropically from initial pressure of 30 bar. If the first the pressure was 30 bar and 350 degrees Celsius. So always remember, my student, in any graph of the world, to locate a particular point, to get a particular point, you need at least two information of two axes. Always remember, this is the universal truth information, that if you want to get a intersect point of any graph, you need at least two information from two axes. So that suppose this is one line, this is another line. So at that time you will get the intersection point. So with only one information you will get a straight line or a line of any graph, but to get the intersect point you need at least two information, so which will give you the intersect point. So you see that the first one, initially the pressure was 30 bar and the 350 degree Celsius temperature. So there are two information. One is the information of pressure 30 bar, and another one is the information of temperature 350 degrees Celsius. Okay, so can any student tell me that which steam it was at first?
There might be superheated steam.
Yes, it will be superheated steam because you can see the temperature is 350 degrees Celsius. Okay, so it will be basically, first of all, it will be superheated steam. We will see this when we plot this into the graphical representation. We will see it will be superheated steam. You see that this is the initial point, and you have to expand the steam isentropically, and then the pressure will be become 1 bar. So we can easily say that there are two position, that is, one is initial position, then the final position. Okay, so we give the initial point and the final point as A and B, because there will be 2 points. One is A point, another is the B point. A point is the initial point and the final point is the B point. Okay, so in the A point, my student, what are the information? That means the initial pressure, that is 30 bar, and the 350 degrees Celsius. So we take A equals to 30 bar and 350 degrees Celsius. And for the B point, B, so we have one information, that is 1 bar, but there is no other information directly given. But indirectly, what is given? That it is isentropic process. So that means the entropy remains same entropy, or SA equals to SB. SA equals to SB. So that is another information. Okay, so in the both point A and B, we get two information individually. So let's take this point, take this information, and put the 2 points in the Molier chart. Identify the 2 point in the Molier chart. Okay, then we will go to what about the the example, the question, that the enthalpy drop and the final condition of this steam. Then we will find out. But first of all, we need to put the amount of point that we have here. There are the 2 point. One is A point, another is B point. A point is 30 bar and 350 degrees Celsius. Okay, so let's find out into the Molier diagram. In the meantime, you can give everyone, you can give your role in the chat box. All. There are total 10 students right now. Please, everyone, give your role in the chat box. Okay. Let's see, my student. First of all, you can see the first point, A point, is 30 bar and 350 degrees Celsius temperature. Okay, 30 bar and 350 degrees Celsius temperature. So first of all, where is 30 bar? Where is 30 bar? We already find out. You see that this is 20
Yes,
bar
it's
line.
the above. Yes, sir. Next to
This is 50 bar line. Okay, we just find out there are 3 boxes here and the difference is 30. The difference is 30 and there are 3 boxes. So every box is 10. So if this is 20 bar, the next line will be 30. Okay, so I draw the whole line will be 30 bar. The whole line will be 30 bar. Am I clear? Okay, so this is the one information, the 30 bar. The another information is 350 degrees Celsius temperature. Okay, so where is the 350 degrees Celsius temperature? You can see that here. This is the 350 degrees Celsius temperature. So if I draw the line one more time, the 350 degrees Celsius temperature, then I will get, my student, the intersection of this point. This is the intersection point, the blue point. You can see that the intersection of the point of these two information, one is 30 bar, another one is 350 degrees Celsius. This will be our initial point, or the point of A. Am I clear?
yes, sir.
Okay, so we got the A point. Okay, let's remove the A point. Okay, so we already got A point. So what is the B point? The B point information is, my student, you all know that it is the pressure is 1 bar. Okay, where is the 1 bar? You can see this is the 1 bar pressure. So let's draw the line. The whole line is the 1 bar. Remember, This, the whole line is the 1 bar pressure line. Okay, the whole line is the 1 bar pressure line. But my student, the interesting thing is that we have only one information. And what is the another information? The another information is the same entropy of the SA and SB. That means the entropy of A point and the entropy of B point will be similar, same. Entropy of A point and entropy of B point will be similar. So my student, what is the A point entropy? This is the entropy scale. Remember, this is the entropy scale. So if I want to find out the entropy of A point, I have to draw the perpendicular line from A to the scale. So if I draw the perpendicular line of the A, this is the entropy of the this point, the blue point. This is the entropy of the A point. Okay, remember the question was the entropy of A point and the entropy of B point are same. That means isentropic process. So A point and B point entropy are same. Remember, if both the point are same, at that time you will get the same entropy. So that means the B point will be also in the same line of the perpendicular. At that time, both the entropy will be same. So the B point is the intersection of this perpendicular line. At that time, the B point entropy will be also same as A. Otherwise, if the B point is just here, at that time the entropy will be lesser. If the B point is here, the entropy will be the bigger. But to be the same exact entropy as A, the B point should be on the same perpendicular line. Is it clear to my student? Is it clear, or I need to explain more here?
Yes, sir. Yes, sir. It's clear.
Again, I'm telling, let me clear everything. Okay, you see that this is the A point. So what is the A point entropy? If I want to find out the A point entropy, I need to draw the perpendicular line. So this is the A point entropy. Okay, I was told that the point of A entropy and the point of B entropy are same. So if the B point should be in this perpendicular line. Why? Because otherwise, if the B point is here, if I draw the perpendicular line here, the entropy will be less than A. If the B point is here, and if I draw the perpendicular line here, the entropy will be the bigger one than A. So to remain the same, because the condition is SA equals to SB, both the entropy will be same. So the condition to remain this condition, the B point should be and must be on the perpendicular line of A. So that's why my student, you see that this is the 1 bar line. So the B point, to get the B point, we have to draw a perpendicular line from A to B. So the intersection point will be the B point. Clear? The intersection point will be the B point. So you can also remember in this way that when it is isentropic process, you have to draw the perpendicular line. You have to draw the perpendicular line. Now the question is, sir, why it is from upside to downside? Because the pressure is 1 bar. Suppose the pressure was 200 bar. This is the 200 bar line. So at that time, the perpendicular line will be the upper side. Okay. At that time, the perpendicular line will be the upper side. The perpendicular line direction from upward and downward will depend on the another information. Okay. So this is the A point and this is the B point. Now this is the initial point A, the original point A, and the final point is B. So the question was, what is the final condition of the steam? You can see here from this that the initial point, the original point, was in the superheated steam region. in the superheated steam region. So the initial steam was superheated steam, but this process, after this process, you can see that the final point is in the wet steam region, isn't it? The final point is in the wet steam region. So the final condition of the steam will be wet steam, because it has crossed the dry steam line and entered into the wet steam region. So the final point of the steam will be, or the final condition of the steam will be wet steam. And it's not complete the information. If it is the wet steam, you also need to give that what is the dryness fraction of the wet steam. So the dryness fraction will be, if I draw the line, you can get it that it is the 0.9. The dryness fraction is 0.9. Suppose the point is here, suppose the B point is here, what will be the dryness fraction? At that time we need to draw the dryness fraction line like this. So it is in between 0.85 and 0.9. So at that time it will be 0.87 or 875. Okay, let's ask one more question. Suppose here we get the B point here. Can anyone tell me what is the dryness fraction of this point?
7.4.
Can anyone tell me what is the dryness fraction value?
Sir,
7.4 something.
0.95.
No. You see that this is 0.95 and this is 1. So the value will be
0.98,
in
sir.
between. 0.97.
7 maybe.
So this will be 0.97. So in the same manner, suppose it is in this point. So it will be in between. So you have to calculate like this. So the first thing is that what is the final condition? The final condition is it is the wet steam and the dryness fraction is 0.9. Okay. The next question was, what is the enthalpy drop? So the drop means when we come from A point to B point, you see that the A point, it is superheated steam, and in the wet steam, so there will be an enthalpy drop. So to find out the how much enthalpy or heat is reduced, we find out the A point enthalpy and we find out the B point enthalpy, and we subtract the two value, we get the enthalpy drop. Okay, so the A point enthalpy is probably, if you go here, this is 3100, something like this, or it may be there is a tolerance level. If I measure by my eye, it can be 3100. If you measure, you can be 3105. So that is not a big problem. Okay, this small change is not a big problem, but it cannot be so much change. Similarly here it will be you can see that it is in between 2400 and 2500. So I can consider this is 2450. I just consider. So in this way, if I subtract this value, I can get this enthalpy drop. Okay, so let's see that what are the value here. You can see they have find out that from Molier chart, the first enthalpy, the A point enthalpy is 3110 and the B point enthalpy is 2450. So what is the enthalpy drop? The enthalpy drop is the difference between the 2 point, that is 660. Okay, and at the Molier chart, the point B is located at the wet steam region. So the final condition of the steam is wet steam and the dryness fraction is 0.9. Okay, so in this way we will use the wet steam, the Molier chart. In this way we will use the Molier chart and we will find out the value. So let's see another example, and I think that will be much more helpful to understand the chart much more clearly. Okay, so the process is always same, my student. The process is always same. It is the point, probably the point might change, the 1 point, 2 point, or 3 point. Okay, the point might change, but the process is always Same. You see that first of all, a sample of steam at 200 degrees Celsius and a pressure of 0.7 bar. So this is the starting point. At the starting point, the temperature is 200 degrees Celsius and the pressure is 7 bar. It is first expanded at a constant enthalpy. At a constant enthalpy to 0.3 bar to 3 bar. That means starting point is 200 degrees Celsius and 7 bar. The B point, the second point, the temperature is 3 bar and a constant enthalpy. That means A point enthalpy and B point enthalpy are same because it is known as constant enthalpy. So the A point enthalpy and the B point enthalpy will be the same. Okay. And then you see that's why you see that the B point is 3 bar and HA. That means HA, the constant enthalpy of A point and B point are same. What is B? Then at a constant entropy 2.5 bar. So that means in the C point pressure is 0.5 bar and the constant entropy. Now my student, it will be SB, because the SB equals to SC, because there are 3 points. One is A. From A at first it goes to B, then it goes to C. So there are 2 processes from A to B and then B to C. So in the A to B process it is the constant enthalpy. So that means HA equals to HB. And from B to C is the constant entropy. So that means SB equals to SC. Okay, so these are the 3 points. Now we will go to our Molier chart and plot these 3 points easily, and then the question is find out the enthalpy and entropy change during this process. There are 3 processes. There are 2 processes basically from A to B. So in this process, what are the enthalpy and entropy change? And there are another process that is B to C point. So in this 2 process, we will find out what are the enthalpy and entropy change. Okay. Let's plot, put this 3 point A, B, and C. The A point is 7 bar, 200 degrees Celsius. The A point is 7 bar, 200 degrees Celsius. Let's go to the next slide. You see that A point is 7 bar and 200 degrees Celsius. You can see here, my student, that 200 degrees, this is the 200 degrees Celsius line. So let's draw a 200 degrees Celsius line. Okay, this is the 200 degrees Celsius line. Okay, where is 7 bar? My student, here you can see. You see that this is the 4 bar line and this is the 10 bar line. So every, you see that in every box that is 2. So the next bar is 6 and next is 8. So 7 bar will be in between. In between it will be 7 bar. So if I draw the 7 bar line, it might be, in my, as I'm drawing by my hand, it might be changed. So this will be in between. So in this way, we will first find the A point, the first A point, that is the intersection point. Okay, so this is the A point from 200 degrees Celsius and 7 bar. Then it is told that the pressure is 3 bar and constant enthalpy. Okay, so the constant enthalpy means the A point enthalpy. Let's find out the A point enthalpy. This is the A point enthalpy. So the constant enthalpy, so the B point enthalpy, it will be also in the same line, in the same perpendicular line. So the B point will be also in the same perpendicular line because the enthalpy A and enthalpy B are same. HA, HB. Enthalpy A and enthalpy B are Same. Okay. So another information is that for the B point, it is the pressure is 3 bar. You see that this is 2 bar and this is 4 bar. So in between it will be 3 bar. So let's draw the line of 3 bar. So the 3 bar line and this perpendicular line intersects the B point. You know, you might in my hand it is might be, you know, wrong, but when you draw by using pencil and scale, it will be straight. So in this way we get A point and B point. This is the A point and B point. And then it is told that the pressure becomes 0.5 bar. So this is 0.5 bar line, and the constant entropy, the entropy are constant from B to C. So this is the B to C entropy line, the perpendicular line, and the intersection point is basically C. So one shortcut for you, when it is the constant enthalpy, you draw the perpendicular line horizontally. When it is told that the constant entropy, you draw the perpendicular line, vertically. You draw the perpendicular line vertically. When it is constant entropy, when it is constant enthalpy, you draw the perpendicular line horizontally. Okay, so in this way, my student, we get the point A, B, C. Is there any question from your side that how we got this point A, B, C?
Sir, B to C again.
Okay, he said that B to C. My student, this is the point of B, and we are told that that the pressure now at the C point is 0.5 bar. Okay, so let's draw the 5 bar first. This is the 0.5 bar line. And it is another told that the B point and C point entropy are same. The B point and C point entropy are same. So if I draw the B point entropy, if I want to find out B point entropy, I have to draw the perpendicular line. This is the B point entropy. Okay, so you see that we know that the B point entropy and C point entropy are same. So the C point should be in the same line. Otherwise, the two entropy will never be the same. So the C point will be the same line. You see that? So the 0.5 bar line, 0.5 bar line and the B point, okay, the 0.5 bar line and this entropy line intersects the point C line. Now it is clear.
Yes, sir.
Okay, so in this way we find out A, B, C, and the first process is A to B and B to C. Can anyone tell me what is the final condition of the steam? What is the final point? A, B, C.
Wet steam, sir.
Yes, the final
wait,
point
sir.
is C point, my student. The final point is C point, and it is in the wet steam region. So the final condition of the steam is wet steam. And what is the dryness fraction? It is 0.95. 0.95. But now the question is that there are two processes. One is A to B and B to C. Okay, so in these two processes, what are the entropy changes and what are the enthalpy changes? So we will first of all find out all point A, B, C, all 3 points entropy and enthalpy. How? Let's draw the perpendicular line. Whatever the value here you can see, you can find out the value from here, this graph. Similarly for C point also, you draw the perpendicular line and you find out the value. In the same way, you draw the perpendicular line to the entropy scale, and in the same way you can draw the perpendicular line to the entropy scale. So these value, this one, you use your graph and find out this value, this one and this one. Whatever the values we'll get, then we will subtract from each other. Let's see that what are the values. You see that they have find out already. After plotting this all three value, we get all three values here. That HA, the entropy at 2840, then entropy is 6.85. In this way we get all the 6 values. Okay, so now what we'll do, we will just subtract from A to B point. You see that from A to B process, the enthalpy change, from A point to B point. So we put the value of enthalpy A point and B point, and we see that there is no change, because from A to B it was the constant enthalpy process. So that's why you see that there is no enthalpy change. The enthalpy change is 0. But for entropy change, the B to A to B point, the bigger one is 7.25 and the smaller one is 6.85. So that means 0.4 kilojoule per kg. This is the entropy change. The second process is B to C. The enthalpy change from B to C, you just subtract. That means you just need to find out the difference between the two enthalpy. So 2840 minus 2530, that is 310 kilojoule per kg. In a similar manner, you see that the entropy change, and you can see that both the value are same, and the change is 0, because the B to C was the constant entropy process or the isentropic process. That's why you can see that the change is 0. And the final condition of the steam was wet steam, and the dryness fraction is 0.95. Is it clear, my student?
Yes,
Yes, sir, it's clear.
Okay, that's it for today. And you know that day after tomorrow we have another class, but in 9th February we have our midterm exam, but the syllabus will be not included by today's class. The syllabus will be till steam properties, the yesterday or the last week, till last week the syllabus will be of the midterm, and there will be the 2 section. One will be the viva, which will happen on the 9th, and another section, it might be assignment, it might be quiz, but I will inform you as soon as possible that what I will take. Is it assignment or is it quiz? Okay, so that's it for today, and I will upload this video lecture as soon as possible, and that's it. Do you have any inquiries?
no, sir. Thank you, sir.
Okay, let me take the roll call. Let me take the roll. Today is 2nd February. Date 27 batch. Date is 2/2/2021. Okay, let's take the roll first from the beginning. Roll 27, roll 16, roll 23, roll 19, roll 37, roll 22.
Yes, sir.
Roll 33. No, it's not required. I'm just taking the roll. Roll 33, roll 35, roll 28, roll 17, and anyone else? Roll 17, roll 15. Anyone else? Anyone? Anyone is left?
No, sir.
Okay. So that's it for today, my students. See you in the next.